Hi, welcome to my video on rational functions, and this video is going to be on the reciprocal function f of x equals b over x plus a plus k, where a, b, and k belong to the real numbers. When I say belong to the real numbers, but we normally in explaining this or doing them, we don't have irrational numbers. So let's look at the reciprocal function. Graph f of x equals 1 over x. So we have x, the reciprocal is 1 over x. So the first thing I do is that I put 1 over x plus 0. And then I write y is the f of x equals 1 over x plus 0. So let's look at this, the graph of this. So let's look at what we call the y-intercept. The y-intercept is when you let x equal 0. So y equals 1 over x plus 0. So x is 0. So 1 over 0 is undefined. So that means that y is undefined. And so that means we have no y-intercept. And let's look at when we have the looking for the x-intercept. The x-intercept is when y equals 0. The equation, we put 0 in the place of y, 1 over x plus 0. And notice that we have a fraction, so we multiply by x. 0 times x is 0, and 1 over x times x is 1, and we have x times 0 is 0, so 0 equals 1, so that means we have no x-intercept. So we have no x-intercept, no y-intercept. So it won't pass to the x-axis and it will not pass to the y-axis. So let's look at a table of values for this equation. So the equation is y equals 1 over x plus 0. So let's look at a negative 3. If x is negative 3, we get negative 1/3. X is negative 2. Put negative 2 here, we get a negative 1/2 because it's reciprocal. X is negative 1. 1 over negative 1 is negative 1. And we have a half, negative 1/2. So we have 1 over a negative 1/2 is equal to 1 times negative 2 over 1, which is negative 2. Again, you can see that we're looking at the reciprocal. Negative 1/4, the reciprocal of that is a negative 4. And we have, again, 0. So we have 1 over 0, that's undefined. And 1/4 reciprocal is 4. 1/2, the reciprocal is 2. Reciprocal of 1 is 1. Reciprocal of 2 is 1/2. Reciprocal of 3 is 1/3. So let's have a look at graphing these. So we have negative 3, which is here, and y is a negative 1/3. So approximately, put it right there. X is negative 2, which is here. We have a negative 1/2. X is negative 1, negative 1. Negative 1 gives us negative 1. X is negative 1/2, we get a negative 2. Negative 1/2, we get a negative 2. And negative 1/4, there's a half there. Negative 1/4 is here. So we have a negative 4. So it's right there. And 0 is undefined. So undefined means, I'm putting down the broken line here. So this is what we call a vertical asymptote. So vertical asymptote is x equals 0. So this graph will not cut this vertical asymptote because the denominator can't be 0. No value. There's no value of x on the y-axis because x cannot be 0. It's a vertical asymptote. VA for vertical asymptote. Now let's look at 1/4. 1/4 is here. We have a 4. It's half gives us 2. Half gives us 2. 1 gives us 1. 2 gives us a half. to a half. 3 is right here because it's 1/3. So you notice that it's looping like this. Notice we have a vertical asymptote. And there's another one, so it's moving this way. And again, this. So notice the closer you get to 0 here, this is going to infinity. The closer you get to 0 on this side, it's going to negative infinity. So that means this is 0 here. So if you look at this equation right here, if x goes to infinity, 1 over x goes to 0. So if x is going to infinity, that means that y is going to approaching 0. So as x goes to infinity, y goes to 0. As x goes to negative infinity, so negative infinity, so 1 over a large negative number is approaching 0. So y is approaching 0. So as x goes to negative infinity this way, this graph is getting closer and closer to the x-axis. Y approaches 0. Y is 0 on this line. And if we take one step further, as x approaches, another way to look at, as x approaches 0, now you're coming 0 on this side, so we say that's 0 on the positive side. So that means y is going to infinity, positive infinity. So as x gets smaller and smaller, closer to 0, this gets larger and larger and larger. And as x approaches 0 on the negative, so that means it's approaching 0 on the negative, that's on the left side. So it's going down. The closer you get to 0 here, the larger this number gets. So y is approaching negative infinity. And you see more of this when you do limits. So I just wanted to mention all that. And besides, another way to look at this also is that this is 1 over x. So that means that if x is positive, then y is positive. So that means it's in this quadrant because x is positive, y is positive. If x is negative, 1 over x is negative, so y becomes negative. So if x is negative, y is negative, so that means it's in these two quadrants. As this is the vertical asymptote, this is the horizontal asymptote. So the horizontal asymptote is y is equal to 0. So that's explaining this reciprocal function. So let's do some more examples when it's flipped over, shifted to the left, etc., etc. What about f of x equals negative 1 over x? So the equation is y equals negative 1 over x, again plus 0. And I have the same idea again, but right here we have let's look. We have a vertical asymptote, so x can't be 0, so the vertical asymptote is x equals 0. So this is a broken line going down to 0 as a vertical asymptote. And as x gets large, then negative 1 over x approaches 0, so that means the horizontal asymptote is also y equals 0. Notice, because we got 1 over x, then the horizontal asymptote is this number out right here. And we have a horizontal asymptote. There it is there with a broken line. And you can't see it because it's on that line. That means the graph, as you approach this side, let's see if just then it was positive. Both of them are positive versus this quadrant and this quadrant. Now we have this is negative. So if x is positive, let's say x is 1. If x is 1, y is negative 1. So that's there. If x is 2, put 2 here, y is negative a half. So you can see it's in here. And if x is negative 1, negative 1 divided by negative 1, y is 1. So if x is negative 1, y is 1. So that means, because we have these asymptotes, and in relation to the vertical asymptote, so if you've got a vertical asymptote, the graph will go close to the vertical asymptote. Either going up here or going up here. Or it could go down this way or down this way. So since the points are in here, this graph is doing this. And this one is doing this. And I did this point and this point to see what quadrants. So is it here, here, or where is it? So by doing extra points, you can tell where it's going to be. And again, it has no x-intercepts and no y-intercepts. Let's look at number 2. And we got equal to, plus 0. So the equation is y equals 1 over x minus 2 plus 0. And let's look at the vertical asymptote. So the vertical asymptote is when you let your denominator equal 0. So let x minus 2 equal 0. X is equal to 2. And again, because it's 1 over, as x gets larger and larger and larger, this fraction gets smaller and smaller and smaller, approaching 0. So that means the horizontal asymptote is y equals 0. So we got a vertical asymptote at 2. So x is 2 right here. So that means the vertical asymptote is a broken line, not a part of the graph. And that's x equals 2. The horizontal asymptote is this number on the end here. So we do a broken line. There it is. And so that's y equals 0, x equals 2. So that means the graph is approaching this asymptote. It's either going up this way or up this way, or it's going down here or down here. But it has to approach this asymptote. Either you won't see it, it'll approach it going up or this way going up. Let's see. So let's take some points. Let's look at the point when x is 3. When x is 3, 3 minus 2 is 1. 1 over 1 is 1. When x is 3, y is 1. Right there. And notice, if these numbers are positive, 1 over a positive number makes the y positive. So that means that the graph is in like this. And if we take 1, so we put 1 in here, take x is 1, put a 1 in here, we get negative 1. 1 over negative 1 is negative 1. So 1 gives you negative 1. Again, this is a vertical asymptote, so it has to go down this way. And if you let x equals 0 in this equation, if you let x equal 0, which means you're looking at the y-intercept. So if you let x equals 0, you get y equals 1 over 0 minus 1 plus 0, which is negative a half, plus 0 is a negative a half. So 0 gives us a negative a half. So 0 is a negative a half here, so that's another point. But notice we have a y-intercept, but we have no x-intercept. Okay, let's continue. Let's graph another one. What about the f of x equals 1 over x plus 1? So y equals 1 over x plus 1. So instead of f of x, easier to use a y. And we got a vertical asymptote. We have a denominator of 0, so x equals 0 is the vertical asymptote. So the vertical asymptote is right here, and it's x equals 0, the broken line. The graph will not pass through this line, x equals 0. Now, let's look at the horizontal asymptote. The horizontal asymptote, as x gets larger and larger and larger, 1 over x gets smaller and smaller and smaller, approaching 0. So that means y will approach 1. So now the horizontal asymptote is 1. So there it is right there. So that's y equals 1 is the horizontal asymptote. X equals 0 is the vertical asymptote. And again, it's either going to approach this way or this way. So let's see. Let's take 1. We take 1, put a 1 in here. 1 over 1 is 1. 1 plus 1 is 2. So a 1 gives us a 2. What about if we go on the negative 1. So if we take negative 1, 1 over negative 1 is negative 1. Negative 1 plus 1 is 0. So we have a x-intercept. When we let y equal 0, we will get a negative 1. So that means that the graph will do this, and it will do this. So you can see that, again, because it's positive right here, because this is positive, the graph will be here and here. And if it was negative, it would be in here and here. So these are the asymptotes. Number 4, we have f of x equals 1 over x plus 1 minus 2. So y equals 1 over x plus 1 minus 2. F of x is a y, and so the vertical asymptote is when you let 1, x plus 1 equals 0, x is negative 1. So the vertical asymptote is negative 1. So negative 1 plus 0, negative 1 plus 1 is 0. 1 over 0 is undefined. So if x can't be negative 1, y can't be negative 2. So vertical asymptote is at negative 1. So down through here is the vertical asymptote. So as x equals negative 1. So the horizontal asymptote is if x can't be negative 1, then y can't be negative 2. But let's look at it another way. As x goes to infinity, as x gets larger and larger and larger, this fraction gets smaller and smaller and smaller, approaching 0. So that means y approaches negative 2. So y is negative 2. It's right here. Y equals negative 2. X equals negative 1. And again, this is positive. So if x is positive, y is positive. So that means the graph is in here and here. Let's see. Let's put a 0 in here. If x is 0, that's a 1. We get a negative 1. So if x is 0, we get a negative 1. And let's go on the other side. If x is negative 2, x is negative 2. Negative 2 plus 1 is negative 1. 1 over negative 1 is negative 1. Negative 3. So negative 2 gives us negative 3. So you can see that it's... Now, if you let y equals 0, it will cross right here. So let's go and let y equals 0. So the equation is y equals 1 over x plus 1 minus 2. So we're going to find the x-intercept. And the x-intercept is when we let y equals 0. So 0 equals 1 over x plus 1 minus 2. Now we solve this. We can go negative 1 over x plus 1 equals negative 2. And put it over 1 cross multiply. Negative 2x minus 2 equals negative 1. Negative 2x equals negative 1 plus 2. Move up here. Negative 2x equals 1. Divide by negative 2, we get a negative half. So that means x is negative a half when y is 0. X is a negative a half when y is 0. So we knew this was going to happen. So there's, that goes here and it goes through here, so it comes down. Okay, so you can see, again, this is positive. So this, if this number is positive, then this fraction is positive. That means y is going to be, if we take, it's going to be positive. Because again, as you take a fraction that comes into here, as the fraction moves into here, this goes to infinity. It gets larger and larger and larger. Just check that out. If you put a negative a half in here, you'll work it out to be a 0. If you put a negative 3/4 or a negative 9 over 10, approaching negative 1, then this will get larger and larger. The closer you get to negative 1 here, the larger this y value becomes, but it's going to be positive. You can check it out. And just a couple of more to do, just to keep explaining. And we have this one, so we have y equals negative 1 over x minus 3 plus 0. So the vertical asymptote is when your denominator is equal to 0. X minus 3 is equal to 0. That means x is 3. So your vertical asymptote is at 3, which is right here. So there's x equals 3. So the graph will not cut through this vertical asymptote. And the horizontal asymptote, HA, is, again, when x gets very, very large, this number is very, very large. The fraction gets very, very small, approaching 0. So y approaches 0. So the horizontal asymptote is the x-axis. There it is. So either the graph is in here or it's here. So let's pick a number. Let's pick we got a 3, let's pick a 4. X equals 4. Let's put 4 in the equation and see what we get. So if we put 4 in, we'll get a negative 1. 4 gives us a negative 1. So that means the graph must be in here. So there it is. And let's put x equals, let's take another number. We take 1 or to make a difference. We can take 1 or 2. Let's take x equals 1. So y equals negative 1. And we're putting a 1 in here. So we get 1 minus 3. And that gives us negative 1 over negative 2, which is a half. So this point right here is 4, negative 1. This point here, x is 1, we get a half. So when x is 1 right here, we get a half. So that means the graph is in here. This is an asymptote, so it goes up like this and goes like this. Again, a negative. If x is positive, this becomes a negative fraction. So x is positive, y is negative. X is positive, y is negative in this quadrant. In this section, I say quadrant, but looks like a quadrant. Let's look at number 6. Number 6, notice the denominator, and I'm going to write it down here. So f of x is a y, but let's rearrange negative x minus 1 plus 2. Shift this around, so I'm not moving across an equal sign, so this just becomes negative x minus 2. So that becomes negative outside of x plus 1. I remove the negative from the leading term, and it makes an x plus 1. So that's negative 1 over x plus 1. So something just a little bit different. Sometimes you have to factor or manipulate the numerator and denominators to make polynomials in descending order. Now we have a vertical asymptote here. The vertical asymptote is x plus 1 equals 0. So x is negative 1. So x is negative 1, vertical asymptote. And we have a horizontal asymptote. And the horizontal asymptote, as x gets very, very large, the 1 over becomes very, very small, approaching 0, so y approaches 2. So y is 2, right here. So y equals 2. So we have a vertical asymptote and a horizontal asymptote, but one cut through. So let's look at this equation. So this is, if x is positive, that means that y is going to be negative. So that means the graph is in this quadrant and this quadrant. But let's check and see. Let's put a 1 in to see if we're right. Or we can put a 0 in. Let's put x equals 0 in this equation. X equals 0. If x equals 0, we get y equals negative 1 over 0 plus 1 plus 2. That means we get negative 1 over 1. That's negative 1 plus 2. So y is 1. So that means we have the point x is 0, y is 1. If x is 0, y is 1. So we're right there. So it looks like we're in this quadrant. Or I say this section here, I say quadrant. It looks like a quadrant, like divided in 4 pieces. So this section, and that means the other one is, let's check the that's negative 1. Let's check the negative 2. So x equals negative 2, y equals negative 1 over negative 2 plus 1 plus 2. That's negative 1 on top. The denominator is negative 2 plus 1, negative 1. Negative 1 over negative 1 is 1 plus 2 gives us 3. So negative 2 gives us 3. So negative 2 gives us a 3, so that point is there. So here it is. So you can see that the graph, again, you can see that this is the horizontal asymptote, because as x gets very, very large, this fraction gets very, very small, approaching 0, so that means y approaches 2. So as you come in here, you go, it's going to go, it's in this section, as this approaches negative 1 on the right side, it goes to negative infinity. As it approaches negative 1 on the left side, which is coming in here, then it approaches positive infinity. So that's the reciprocal functions, rational functions. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.